You ever wonder why those huge, really ambitious projects, especially in the world of software, so often end up late, way over budget, or just fail? Today, we're going to dive into a classic book that totally nailed this problem decades ago, The Mythical Man Month. We're going to unpack its timeless lessons about why building big things is just so incredibly hard.
The author, a guy named Fred Brooks, kicks things off with this proverb. And it's such a great way to think about it, right? We can learn from the shipwrecks of others. All those failed projects from the past, they can actually guide us. They're like lighthouses, helping us steer clear of the very same rocks. So, what are those rocks? Why do these massive projects just get completely stuck? Brooks paints this really vivid picture from prehistory, a tar pit. Where even the mightiest beasts, dinosaurs, mammoths, got trapped and just sank. And he argues that this is the perfect metaphor for large-scale software development. So let's really dig into this metaphor, the programming tar pit. Brooks says this is the absolute key to understanding the challenge, because the danger isn't some single fatal flaw. No, it's something way more insidious than that. And when you're stuck, what's your first instinct? To struggle harder, right? But in the tar pit, the more you thrash around, adding more people, more pressure, the more entangled you become. And things just get worse and worse. So here's the crucial point. The tar isn't just one thing. It's not like you can solve one problem and be free. You can pull one paw out, but you're still stuck. It's this messy buildup of small, interacting problems. Bugs, communication issues, changing requirements that just grinds all progress to a halt until the whole project sinks under its own weight. Okay, so this leads to a pretty common puzzle. We've all heard those stories, right? Two programmers in a garage build something amazing, while a huge corporate team just struggles. How does that happen? Well, the answer lies in this huge and often invisible difference between a simple program and a real-world product. Let's start with the baseline, what Brooks calls a program. This is basically the garage version. It's a piece of code that works, but really only for the person who wrote it, on the exact machine it was built on. It's that raw, functional core. But here's the thing, to make that program actually useful for other people, you have to turn it into what he calls a programming product. And that one step, he estimates, costs 3 times the effort. So why 3 times as much? Well, first, you have to generalize it so it can handle all sorts of different situations. Then you have to build a whole suite of tests to make sure it's actually reliable. And finally, you have to write clear documentation so other people can actually use it or fix it. This is the unglamorous but absolutely essential work. But hold on, we're not done. There's another multiplier. What if that program isn't just a standalone tool, but it's a single piece of a much larger system? Think an operating system or a big application. Well, that transformation also costs 3 times the effort. This is what it takes for your little program to become part of a programming system. Your code now has to play by really strict rules, these interfaces, so it can talk to all the other parts of the system. It has to live within a tight budget of memory and processing power. And the testing, it becomes exponentially harder because you have to check how your piece interacts with every other piece. So what happens when you need to do both? When you need a component of a large system that is also a robust, documented, and tested product? Well, you multiply the multipliers. 3 times 3 is 9. And this, right here, is the core insight, the real goal of most professional projects. What Brooks calls a programming systems product is 9 times harder to build than that first simple program. That 9x factor is where schedules go to die because it's almost completely invisible when you start. So given this immense difficulty, this, tar pit of challenges, why in the world would anyone choose to do this work? Well, it's because alongside all the woes, there are some pretty profound joys. Brooks points to 5 deep-seated rewards. You've got the simple, primal joy of creation, of just making something. Then there's the satisfaction of seeing other people find your creation useful. You've got the intellectual thrill of building these incredibly intricate, puzzle-like machines, the fact that you're always learning. And finally, there's the magic of the medium itself. I absolutely love this quote. It just captures the unique freedom of programming. See, unlike a sculptor who's working with stone, a programmer is working with pure imagination. They build these huge, complex structures, literally out of nothing but logic and thought. They're creating things that, as he says, never were nor could be. But, of course, every joy has its shadow. And that same magical medium brings its own unique set of frustrations, what Brooks calls the woes of the craft. So here's the fundamental tension. It's a total joy to work in a medium that's as flexible as thought. But the computer demands absolute, total perfection. It's like a magic spell. You get one character wrong, one misplaced comma, and the whole thing just fails. And let's be honest, humans are not built for that kind of perfection. It is a constant source of frustration.
And there are other woes, for sure. You rarely have full control. You're always depending on someone else's code, which is often buggy or poorly documented. Hunting down those tiny little bugs is just tedious work. And then, right when you finish, it can feel like your amazing creation is already obsolete. It's a really tough environment.
So where does that leave us? Are we just trapped between these profound joys and immense frustrations, stuck in a tar pit that we made for ourselves? Well, Brooks's goal isn't just to describe the pit, but to suggest how we might actually build boardwalks across it. Ultimately, I think you have to hold both of these truths at the same time. Programming is a dangerous tar pit where great ideas have sunk, but it's also this deeply human and rewarding creative act. And that really leaves us with a final thought. The lessons from this 50-year-old book on software feel more relevant today than ever. We all face our own complex projects, right? Our own tar pits, whether we're in business, science, or art. So the real question for all of us is, how do we recognize the true cost of our ambitions? And how do we build the boardwalks that let us get across that complexity without sinking?